and I'm still recording the lecture and post it, and if basically let me know if you have like difficulty seeing anything, just ask me. So now we're on part 5, chemical formula as conversion factor. And then to teach this concept, your book gives an example of a clover. And maybe this is a good thing that I can also show you the book, which is much nicer than what I have here. But for my purpose, you can see that if you consider this as a clover, you see that we have like 3 leaves in one clover, right? 3 leaves. And also your book gives some other examples. So now I take advantage of the dot cam so I don't have to paint them basically. So in one each spider has 8 legs. So, and then each chair, or at least this specific type of chair, has like 4 legs. And with the same rationale that we're talking about clover, spiders, chairs, and then we can assign that if you have one chair, we have 4 legs. Or like each spider, one spider has 8 legs. Or one clover has like 3 leaves. We can kind of do the same thing for molecules. That one water molecule has 2 hydrogen atoms. So your book uses these analogies to kind of teach you the concept that I'm going to teach. And basically, as I said, so if we know this, that one clover has 3 leaves, if I ask you that how many leaves are in 14 clovers, so how many leaves are in 14 clovers? And what you need to do in this problem and all other problems that I'm going to give you, or your book asks you, is that just write what you want to find equal to what you are given. And then you write as many conversion factors as needed to find your answer. So here you say how many leaves. So I write how many leaves equals, what do we have? 14 clovers. And you need to write as many conversion factors as needed. So here we have this conversion factor here. We know that one clover has 3 leaves. So here, and as you remember, the thing that you are given, you write in denominator, so you can kind of simplify it. These 2 terms cancel out each other, and then here you write the things that you want to find, which is number of leaves. Sometimes, as I explained later, and we saw in previous session too, you need to write more conversion factors, but you do one at a time. So here you have the direct relation between clover and number of leaves. So one conversion factor is enough. And you say that one clover has 3 leaves. And then 14 multiplied by 3 is like 42 leaves. Any question on this? Okay, so as I explained to you just like a little before, if we have like, one CO2 molecule, you can say in one carbon dioxide, we have 2 oxygen molecules. So basically that corresponds to two oxygen atoms. Sorry, 2 oxygen atoms. So in one CO2 molecule, we have like 2 oxygen atoms. And if you remember the analogy of nails that the book was giving you like 2 sessions ago, we had like the measure of dozen for nails. And in general, we can use dozen for any other concept too. So here I can write that, 1 dozen CO2 molecule corresponds to 2. I'm just making mistakes. 2 dozen oxygen atoms, right? It's kind of like, multiplying both sides by the same number. It doesn't change, So these 2 still would be equivalent, right? And if you remember, we said that in the sense of atoms, molecules, and so on and so forth, we cannot use dozen. It's just too small. And we introduced the concept of mole, which is basically a number, right? Like dozen that corresponds to 12. Mole is 6.022 multiplied by 10 to the power of 23. So here I can write 1 mole of CO2 molecule corresponds to 2 moles of oxygen atoms. So basically, in 1 mole of CO2 molecule, we have 2 moles of oxygen atoms. And this is the thing that I just, explained to you at the beginning, and your books gives, says that chemical formulas as conversion factors. So when you write the chemical formula, you can write a conversion factor based on mole. And this is really important to remember, that this relation here is like based on mole, not based on gram, not based on anything else. This is like mole. So remembering that, if you can write this for other molecules as well. So for instance, for water, you can say 1 mole of water, H2O, molecule corresponds to 2 moles of hydrogen atoms, and it corresponds to 1 mole of oxygen atoms. So basically, when you write the chemical formula, you have like important information about their moles, which is kind of like simple because the number of atoms in that molecule corresponds to number of moles. And this is basically by this rationale that we talked about here. Is it clear? Any question about any of this? Okay. So now that is clear, let's go through an example. So the example is determine the number of moles of oxygen in 1.7 mole of calcium carbonate. Okay, so you are given 1.7 mole of calcium carbonate, and you want to find number of moles of oxygen. So again, anything that you want to find, you write here, you say that how many moles of oxygen is equal to what you are given in the problem, which is like 1.7 mole of calcium carbonate. And then you should write a conversion factor. And you remember how to write the thing that is given, you write in the denominator, so it cancels out, and then you have the thing that you want to find in the numerator. And you see, this problem is easy. It just needs one conversion factor. But sometimes your problem is more complicated, as we are going through after this, and then I'm going to explain to you how to solve those problems. But it's important to consider that, you write as many conversion factors as needed. And then here you see that in calcium carbonate, in 1 mole of that, how many moles of oxygen do you have? What? 5.1, you said? 3. Yes, I mean, this is kind of, yeah. So you said the final answer. So this is, that's correct too. But here, in like just 1 mole of calcium carbonate, you have like 3 moles of oxygen. And then, the final answer is 5.1 mole of oxygen. So are we clear about the chemical formula and how to find the number of moles? This is kind of straightforward, just the number of atoms in each molecule corresponds to its mole in 1 mole of that specific compound. So now I'm going to talk about converting between grams of a compound and grams of a constituent element. So now basically we want to solve the issue that we talked about from the beginning, relating the mass of sodium to sodium chloride. And what you do in this type of problem is that, so here as an example, I just write the problem, then we discuss it. We want to, let's find the mass of sodium in 15 grams of sodium chloride. So like we always do, we want to find the mass of sodium. How many grams of sodium equals to 15 grams of sodium chloride. So do you have any issue just writing this? Is this clear how we do this? So the thing that you want to find, you write here on the left side equals to what you are given. And then here, is it a way, there is no direct way to relate gram of NaCl to to grams of sodium itself. But if you remember, we had an important concept to how relate grams to moles of an element or a compound. Do you remember what it was? How do you relate gram and mole? Yes? So you're close. That is the amount of 1 mole, right? And if we want to find number of atoms, that is the way, because we have like 1 mole equals to 6.022 multiplied by 10 to the power of 23. So that you're in the right track. But here specifically, we want to have like gram of sodium chloride and mole of sodium chloride. There is something that exactly gives us the unit of gram per mole. Atomic mass, yes. Yeah? Yes, exactly. So atomic mass, is being used just for the element, but molar, yeah, so that is correct too. But molar mass specifically has a unit of gram per mole, and we can use it for elements, we can use it for molecules, and any compound, that we have. So yes. So if you remember molar mass, and if you remember this periodic table, now I kind of like the dot cam that I can just like show it to you without having iPad technical difficulties. So, and this is something that you should remember well. You don't have to memorize the numbers, but at some point when you solve multiple problems, you remember carbon that is like 12.01 or like 12 roughly, or oxygen is 16, So the thing that is important is to know how to read these numbers. And as it was told, we have like atomic mass here, which for elements, molar mass is the same as, atomic mass, but for the molecules, it would be your formula mass, which the number equals to your molar mass. So now we want to find formula mass or molar mass of NaCl, right? So here I just write this so we remember how to do this. Mole of NaCl. So any problem that is given that you have the gram of the molecule or gram of the element, and you want to convert it to the gram of the other constituent, you first should convert them to moles. Because in the chemical formula, we have the means to convert the number of atoms to each other. Basically, if you have like carbon dioxide, you can convert it to oxygen, but the means is mole. We cannot do that with gram, because for different elements, the formula for different elements, molar and different molecules, molar masses is different, and then the thing that you can interpret from the chemical formula is moles. So basically you can say in 1 mole of NaCl, you have 1 mole of Na, you have 1 mole of Cl. But you can, if I tell you I have like 20 grams of sodium chloride, how many grams do I have chlorine? You cannot just, say, you should do calculations first, convert them to mole, and then to gram. So anytime you have gram here, you should do some calculations with mole. Are we clear on that? Okay, and now I want to find the molar mass of NaCl, which is this, the numerical value is the same as your formula mass. And then here we come to the book, we read this number, Na is 22.99. 22.99 plus, for chlorine, we have 35.45. So to do this, this is roughly 23. So it would be like 58.40, but here is like 0.01 less. So it would be like 58.44 gram per mole. Always write your unit because it gives you valuable information. So here it's like 1 mole of NaCl has like 58.44 gram. Right? So this is one part of the problem. And then here we have like mole of NaCl because we want to cross that out. So how can we convert mole of NaCl to mole of Na? Do you know? Yes? Yes, exactly. Because from the chemical formula, you see that for 1 mole of NaCl, you have like 1 mole of Na. But still, we don't have the gram. We want the gram of sodium. So we need 1 more conversion factor. And that is simply, here. Basically, you go to your periodic table, you see that Na has the molar mass of 22.99. So I'm just going to write the final answer from the book. So it would be 15 multiplied by 22.99 divided by 58.44, which would be 5.9 gram of sodium. So imagine you solve this problem, and it's like a multiple choice question, and you find out the number is 20. How do you know if that number is wrong? Imagine we solve the problem. Instead of 5.9, I find the number being 20. Exactly. So the amount of sodium chloride is 15. So sodium in that compound should be less than that, right? So this is how you can kind of like see if you made a mistake. One of the answers can be like 59 gram. So you can just like look at it and say, okay, this is not the right number. You can just like kind of like go through like the mistakes that I made in the previous session, kind of like we can just go through, see, does it make sense, the number that I'm having? Okay. And then your book gives a basically solution map that, you have like so basically what we wrote, you have like gram of sodium chloride, you convert it to mole of sodium chloride. And you can convert the mole of sodium chloride to mole of sodium, and then with molar mass, you can convert mole of sodium to gram of sodium. So I'm going to write this really quick. So you remember, you first convert the gram to mole, and then mole of sodium chloride, or like your compound, to a specific element, or vice versa. And then convert it to the gram of sodium. So basically, if we write it like mass of compound would be moles of compound, and then would be moles of element, and then mass of element. These two are kind of like the same. Any question about any of this? Okay. To make sure, okay, and I'll put it here in case you want to write more. So I'm gonna write another example. So carbon, which is C10H14O, is the main component of spearmint oil. It has a pleasant aroma and mint flavor. Carbon is added to chewing gum, liquors, soaps, and perfumes. Kind of to give you, your books, kind of gives a background information so you know that these are kind of like your daily life, So you see the importance of the, Chemistry 101. And calculate the mass of carbon in 55.4 gram of carbon. So you know, when you know the procedure, it doesn't matter if your molecule has like 2 atoms, 3 atoms, 10 atoms, 20, you know, when you know the procedure, you shouldn't be scared if you have like 3 constituent elements, or, you know, sometimes you can have a compound that it has like I don't know, 6 or 10, or like, you know, you can have a large molecule with so many constituents. When you know the procedure, everything is the same. You know, you don't have to be afraid of the length of the molecule. So again, anything that you want to find, you just write it first. We want to find how much basically carbon. So basically I just write gram of carbon. So this is like, you want to find mass of carbon. So how many grams of carbon equals 55.4 gram of C10H14O. So if you know just like the procedure, you know that you cannot just convert grams to themselves. You should convert the gram to mole. So here, the first conversion factor would be gram. This is 14. Okay, I'm just going to write it smaller so everything fits. C10H14O gram. You convert that to moles of C10H14O. Right? And then you have like mole of carbon. You want to convert it to moles of carbon. So you just write mole of C10H14O to mole of carbon. And then finally, you have like mole of carbon to gram of carbon. So this is kind of your solution map. And then you go write each of the conversion factors. So for molar mass of C10H14O, basically it's kind of like your formula map. You go to your periodic table, you see that C is like 12.01. And how many carbon do I have? 10, exactly. Multiply by 12.01. Plus, how many hydrogen? Exactly. And can you tell me the molar mass of hydrogen? Yes, exactly. How many oxygen do I have? And what is the... Yes, exactly. And then, after doing this, so we have 10 multiplied by 12. This is this. It would be 150.2 gram per mole. So here, for 1 mole of carbon, I have like 150.2. So can you tell me for 1 mole of C10H14O, how many moles of carbon do I have? Exactly. It's kind of like you just go to chemical formula, see what is the number of that specific atom in the molecule. And then can you tell me off the top of your head how many grams are in 1 mole of carbon? Exactly. And then when you do this math, the final answer, so this would be 44.3 carbon. And then when you look at the number, you know, the original amount of the gram of the compound, that kind of makes sense because hydrogen is really light and the weight of it is almost 1.01. And oxygen is like 16. So kind of like just looking at the number, it makes sense. If you had the number like 100, you knew something's wrong. But the number, kind of like just looking at it makes sense. So any question about this? Is it clear how we do the conversions? So when there are like some stuff to remember. One is the molar mass and how to calculate formula mass for different compounds and different molecules in general, or different molecules and different compounds in general. And converting between moles and mass for each element or each compound. And then from your chemical formula of the compound, you have the relationship between moles of a constituent element and moles of the compound. So 1 mole of carbon dioxide has 1 mole of carbon, have 2 moles of oxygen. And the same thing for other molecules. Okay, if we're good on this, I go to the next topic, which is mass percent composition of compounds. So basically, mass percent of so if you have for instance, in the NaCl example that we gave, if you consider the mass of a constituent element, such as sodium, divide that the mass of the compound and multiply that by 100, you have mass percent of that specific element in the compound. In other words, you can write mass percent of element X equals mass of X in a sample of the compound. I'm not doing a good job distributing. Divided by mass of the sample of the compound, multiply, which I just write here the rest of it, multiply by 100%. So basically you multiply this fraction by 100 and your answer would be in percent. So let me also show you the book that did a better job writing this. So you know what I mean. So you have mass of the specific element, divide that by mass of the compound, and multiply by that 100. And then you have the mass percent. It's kind of calculating the percentage, If you have you want to calculate number of A's, see how many percent got an A in a course, You kind of count the students that got A, divide that by total number of students, multiply that by 100. So it's the same thing here, You have the mass of that constituent of that element in the compound, divide that by the mass of the compound, multiply by 100. And this is kind of the experimental value. So whether, from a reaction or, in the by other means in the, scientists go to the lab, do some experiments, and then they get this number, this mass percent. And just shortly, I'm going to talk about how to calculate that from molar mass and from the periodic table as well. But in general, this number is an experimental value. So to give you an example about this, I'm just going to kind of walk you through the example 6.8. Using mass percent composition as a conversion factor. it says the FDA recommends that adults consume less than 2.4 grams of sodium per day. I think at the beginning of the class I said 4.2 by mistake. It's 2.4. So remember, don't consume more sodium because I said so. So it's like 2.4 grams of sodium per day. This is the limit. And the question is that how many grams of sodium chloride can you consume and still be within the FDA guidelines? And then it tells you sodium chloride is 39% sodium by mass. Sodium by mass. So you can write this as a conversion factor. So basically this means that in 100 grams of sodium chloride, you have 39 grams sodium. Do you have any questions about writing this conversion factor? This is kind of intuitive, right? That if sodium chloride is 39% sodium by mass, it means that if you have 100 grams of sodium, 39 grams is sodium. And then here, you want to find how many grams of sodium chloride you should consume to be within FDA recommendation, which is like 2.4 grams sodium. And then you write a conversion factor, gram of sodium. You remember that previously I told you we cannot convert grams by themselves. But this is an exception because you are given explicitly the relation between grams of sodium and grams of sodium chloride. But if you are not given this information, you should convert to mole. And indeed, I'm going to solve this problem for you with moles, and you see still we get the same answer. So here, these two cancel out, and then you write here gram of sodium chloride. And then here, you just write this conversion factor. And then remember, your denominator and numerator. Here, for 100 grams of NaCl, you have 39 grams of sodium. So just don't write this 39% as such. Write your conversion factor, see what you have, what you are given, so what you should write in your denominator and what you should write in numerator. But when you kind of understand these concepts, it's just like so easy to write these conversion factors. And then after doing the math, you will have like 6.2 grams of NaCl. And the number kind of makes sense because it's bigger than gram of sodium. So this is kind of straightforward because you are given the mass percent composition and you just write a conversion factor. Any questions about this? Now, I'm going to solve the same problem but with moles. Imagine we're not given the mass percent, and then we want to solve the problem ourselves with the periodic table and molar mass. So the procedure is the same. You write how many grams of sodium chloride equals to 2.4 grams of sodium. Do you remember what is the first step? If I want to solve this with molar mass. First, I should convert the gram of sodium to what? Yes, to moles of sodium. Any question on this? So you have a gram of sodium chloride. This part is just given to you. You just write it down as such. And then here, you convert gram of sodium to moles of sodium. So for the sake of simplicity, I just show it here and then write it down. So 1 mole of sodium has like how much gram of sodium? Yes, 22.99. And then remember, 1 mole of sodium has like 22.99. So these conversion factors, these fractions, numerator, denominator, those change depending on what you want to calculate. But when you know the procedure, it would be straightforward. And then here I convert mole of sodium, and you write it somehow that they can cancel out, to mole of sodium chloride. Can you tell me what this conversion factor is? Yes. So for 1 mole of sodium chloride, we have 1 mole of sodium. And then we convert mole of sodium chloride to what? Can you tell me what is the... Exactly. And then again, you remember that for calculating formula mass, which is the same as your molar mass, you come here, you write down the value of Na and the value of Cl, right? So your Na is 22.99, and then Cl I just draw the square larger for no specific reason. So NaCl equals 22.99 plus 35.5, and then we calculate this just like in the previous example. It's 58.44, and then 1 mole of NaCl is 58.44. And when you do the calculation, you'll be having, I'm just going to use a calculator that is not working. Okay, it's working, I guess. Okay, can someone does this math and tell me the answer? 2.4 multiplied by 58.44 divided by 22.99.
I got 6.1.
Okay. And (6.1). And so this would be gram of NaCl. And you see here that based on experimental value for mass percent composition, we got 6.2. So you see that the numbers are really similar. And the discrepancy is the difference between the calculation and the experimental value. But depending on what I give you in the exam, whether I give you the mass percent or ask you to solve the problem for like molar mass of each element and compound, the answer would be the same. And the procedure just is slightly different. But remember, what you want to find, you write it in the left side of the equation, equal sign what you are given. And you write as many conversion factors as needed. And unless I give you the mass percent, you always convert gram to mole, and then based on chemical formula, convert moles of elements to the 1 mole of compound to specific moles of the constituent element. And then that element, you convert its mole to gram. Do you guys have any question about any part of this? Is it clear? Okay.